So, we have seen the plane mirror. There can be some other types of mirror also. For example, if the surface is curved like this, and this is the polished surface, that is you are standing in front of this, the front of the mirror is curved like this. How do you look at that and what type of image you see of yourself? For that matter, it can be the other way around also. It can be bulging in front of you and polished on the other side. So, here also if you stand here, if you stand here, you see an image here, somewhere here. Here also you will be seeing an image. What type of image are they going to be? Are they going to be exactly the same way you see in a plane mirror, or there will be a difference? What type of difference? But before that, how do you make a mirror curve like this? You know, there are so many types of mirror for that matter. You will have something like this. I have something like an egg shape, solid, okay, egg shape, solid. We are not talking about a two-dimensional thing. Think of it three-dimensional, exactly like an egg it looks. So, if I cut it here, so that portion, it will be a circle here and a flat place. So, when this is a sphere, look at this. If I am going to cut this slice, can you see this? Another circle, I am going to cut it and take it out. If I take out this, how does this look like? It is going to be round in shape. It looks like circle only, exactly the way, but this portion is bulged out. It is not a flat circle, it is a bulged out circle. So, this portion is bulged out. So, from the side, from this angle, it looks like this, isn't it? Can you see that? This line is looking like this. This is where I have cut it off. So, if I take out this portion, now this portion, I have taken it out, and I can do two things with it. Either this portion can be polished, whereas I can look at this and see my reflection, or the other side, the inner side can be polished, in which case I can look at that and see my face. So, either of the two sides can be polished, that makes it a mirror, but it is no more a plane mirror, it is known as a spherical mirror because it is coming out of a sphere. So, from a sphere, if something is cut off, one small slice is made, either it will be bulged out or it will be curved in. Either way, if it is going to be like this and this portion is the reflecting surface, then this mirror is known as concave mirror. This is concave, that means you are standing here, in front of you, you have a surface which is curved like this. Suppose it is like this, then again you are standing here. Now, in front of you, you have a surface which is bulged out like this, it is bulged out. So, if I mentally draw a circle, it will have a center point here. If I mentally draw a circle, I can draw it again here. See, look at this. This is a concave mirror. This is only this much, but if I able to draw a circle around it, that makes it a sphere. If I cut it and again join it, that makes it a sphere, isn't it? A sphere will have a center. Similarly, here, if this is going to be the convex mirror, mentally I can sort of make a sphere out of it. There will be a center. Only in this case I am standing here, in this case I am standing here. Can you see that? This is the reflecting surface here, here this is the reflecting surface. Okay. Now, between the two of them, there are many things that are common, quite a few things are also not common. If this is called a concave, it is bulged inside, then this is called a convex mirror, which is bulged outside. So, it is in front of me, it is curving like this. When I am going to look at that, it is this one, it is coming like this. So, I am looking at this from this side. Okay. Apart from that, there are few terms these mirrors have. For a plane mirror, there are not many terms. There is only one normal, we talk of the plane mirror. But in a concave mirror, there are quite a few terms that we may have to use. Let us go for a simple concave mirror. The same thing also applies for a convex mirror. So, let me draw that for you. That makes it much easier. So, this is a concave mirror. That means when the light falls on this, it will be reflected here. You cannot have a light falling on this and reflected because this portion is not a reflecting surface. You have seen a mirror. Have you ever seen the back side of a mirror? It is generally painted, some orange sort of thing, some compound of silver is put there. That is almost like orangish or bluish sort of color at the back side of it. That makes it a non-reflecting surface. Same way here, This is the non-reflecting surface. Obviously, this is the reflecting surface and this is a concave one. Now, what are the terms that are used in a concave mirror for us to proceed in this field? We have to know a lot of things, how the images are formed and all that. So, there are some standard terms which we will be using again and again and again. So, let us know that. As I told you, if I am going to mentally make a circle out of it, it will have a center. Surely, that center is known as center of curvature. So, this from this point and this point there is a distance, isn't it? So, that distance is known as radius of curvature. So, this point is C is known as center of curvature. This is the mirror, only this portion is the mirror which I have cut out. This point is known as pole. Pole is exactly the center of the mirror which I have cut off. So, it is also in the form of a circle. Can you see that? This is a circle. So, the centermost point, this is known as the pole, that is what it is here. This C you are not able to see because it is lying inside the sphere, center of this sphere, also known as the center of curvature. So, you have a distance Cp. Actually, that is the radius of that sphere, isn't it? Cp, imagine that as a sphere. So, Cp is the radius. So, Cp for our sake, we will call it as radius of curvature. So, this is center of curvature, Cp is radius of curvature. So, already we know 3 points. One is the pole. Pole is the geometrical center of the mirror itself. This is the pole. Center of curvature is that central point of the imaginary sphere from which we have taken out this lens, this mirror. From this imaginary sphere, we have taken out this mirror. That center of that sphere is this C, and that is known as center of curvature. The distance between that center and this pole, that distance is actually the radius of the sphere. For us, we will be calling that as radius of curvature. So, Cp is radius of curvature measured in meters for all practical purpose. You can also use centimeters as in the case may be. Apart from that, few more things. There is exactly a point in between C and P, just the central point. Cf is equal to Fp. This distance Fp is known as focal length of this particular mirror. Focal length of the mirror. What does that mean? Fp is half of Cp. So, Fp is equal to half of Cp, which is equal to, suppose I give you the value of Fp. Suppose I say the focal length of this particular mirror is 20 centimeters. So, what does that mean? This distance is 20, that makes the radius of curvature as 40, double of 20 is 40. What does that 40 centimeter mean? That this particular mirror, if it is made into a sphere, will have a radius of 40 centimeter. So, any spherical mirror, if you imagine it to make it a sphere, then this distance is equal to 40, that is the radius of curvature. Half of the 40 is 20, which is the focal length. So, that is again a length measured in meters or centimeters as we do the problems. Apart from that, this point F, now point should also have a name, that is known as a focus. So, every spherical mirror will have one focal point or one focus. You cannot have 2 or 3 the plural of focus is foci, this is plural is FOCI. So, you cannot have 2 or more focus, there will be only one focus for one particular spherical mirror, because every spherical mirror will have a particular radius of curvature, and focal length is exactly half of the radius of curvature. So, naturally it is only a particular distance. Since this distance is fixed, F is also fixed. So, every spherical mirror will have a focus, will have a focal length, will have a radius of curvature, will have a center of curvature, also will have a pole. So, these are the 5 points we should remember, so that when we draw the ray diagrams, we will be able to proceed properly. Similarly, even for this convex lens, even though I am standing here, because this is the reflecting surface, the inner surface is to the non-reflecting surface. From there, if I make a sphere, again this distance is this is C, center of curvature, this is P, this is radius of curvature, exactly half is the focal length, Fp is the focal length and F is the focus of that convex mirror. Here F is the focus of the convex mirror, concave mirror. Here F is the focus of the convex mirror. So, these are the 5 terms which are common to the both types of mirror: focus, focal length, pole, center of curvature, and also radius of curvature. So, let us proceed and see how we can find what are the rules that are necessary for us to know to draw the ray diagram to find how an image is formed when you stand in front of any of the 2 mirrors.